Good morning, my YouTube viewers. It's Crystal here, and in this video, it's going to be the last video that I make on the Alison course that I took of probability and chance in mathematics. And basically what I did was I took the course material and I converted it to Excel. And so the previous two videos were on Module 1 and Module 2. And this video is going to be on the assessment where I converted the questions to Excel to be able to answer the questions in Excel. And then so if you watch the video on Module 1 and Module 2, you'll see that a lot of the questions that they ask in the assessment were not really fully covered in Module 1 and Module 2, which is why I had difficulty with it. But it's a good thing that I was able to convert it to Excel to do it. In addition to that, if you look at my previous 3 videos to this, then you'll see that I did the coursework in Python. So you have a choice. You can either look at the coursework in Python or you can look at the coursework in Excel. I'm doing it in Excel because most people use Excel, and so I wanted to use a platform that most people use. So it's somewhere in the neighborhood of 16 questions, but some of the questions have been covered previously because some of the questions I put in a tab with Module 1 or Module 2. So it's not going to be totally 16 questions, but we'll go ahead and go through all the questions that I've got. So you have a manufacturer of metal pistons finds that on average 12% of his pistons are rejected because they are either oversized or undersized. What is the probability that a batch of 10 pistons will contain no more than 10 rejects? So you've got 10 N, which is the number of pistons, which is 10. And you've got the probability of rejection, which is 0.12 or 12%. And then you have the maximum number of rejects is going to be 2. So the probability of that is going to be binom.dist brackets B6, B4, B5, true. And so that gives you your cumulative distribution function. So you've got an 89% probability that you're going to have no more than 2 rejects. So the next question that we have is going to be about French class. There are 16 girls and 8 boys in the class. Half of these 24 students study French. The probability that a randomly selected girl studies French is 1.5 times the probability that a randomly selected boy studies French. How many of the boys in the class study French? So you've got total students is 24. You've got French students is 12. And how you did that is that equals floor brackets B5 divided by 2, 1. And what floor does is floor converts the number to an integer or whatever number digits that you want. And I said 1, so it's going to be an integer. Because if it had been 25 students, well, you're not going to be able to have 12 and a half students studying French. So it has to be converted to an integer, which is 12. So let's just use an example here, 25. And you can see it's still 12. So we'll just go back to 24, which is what we had. So you can see that even if it was 25 students, it would be 12. But let's try 26. So it's 13. So and then what we're going to do is, so we've got our 12 French students. You've got 16 girls and 8 boys. And probability that the boys study French equals B6 divided by 1.5 times B7 plus 8. And so that's going to be 37.5% probability. And there's going to be 3 boys studying French because you're going to have B8 times B9 is going to be 3 points. It's going to be 3. So that's how you calculate how many boys in the class are studying French. The next question we have is going to be about events. So 2 events, A and B, are such that PA equals 0.2 and P intersect B equals 0.15 and PA apostrophe intersect 3 equals 0.6. Find the probability that neither A nor B happens. And so that's going to be I'm going to say A union B complement. So probability of A is 0.2. Probability intersects B equals 0.15. Probability A complement intersect B complement is 0.6. Probability A union B is 1 minus B6, which is 0.4. Probability of B equals B8 minus B4 plus B5. So that's going to be 0.35. And probability A union B complement is 1 minus B8, which is 0.6. So that's how you do it. And that's the answer to that. And I looked it up, and that's the answer that it gave us. So the next question that we have is going to be on disc. A bag contains 10 yellow, 6 green, and 4 blue discs. 1 disc is drawn at random from the bag and not replaced. Another disc is then drawn at random from the bag. Find the probability that both discs are of the same color. So you've got total disc. Total disc is 20. You've got 10 yellow disc. You've got 6 green disc. And you've got 4 blue disc. So we're going to calculate the probability that they're the same color. So yellow probability is B5 divided by B4 times B5 minus 1 divided by B4 minus 1. And that's a 23.68%. So probability of green is B6 divided by B4 times B6 minus 1 divided by B4 minus 1, and you have a 7.89% probability. Now we have the probability of blue, so you've got B7 divided by B4 times B7 minus 1 divided by B4 minus 1, and you have a 3.1579% probability. So we're going to check to see if it's the probability of the same color probability is going to be B11 plus B12 plus B13, and so it's going to be 0.347368. So that is the answer to that question. So the next question we have is, in a class of 30 students, 20 study physics, 6 study biology, and 4 study both physics and biology. A student is selected at random from this class. Find the probability that this student studies physics. So you've got total students is 30, you've got physics students is 20, and so probability that they're going to study this physics is B5 divided by B4, which is 67%. So now we have a question concerning a radar. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 kilometers per hour and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling more than 100 kilometers per hour. So we've got the mean speed is 90, the standard deviation is 10, and x is the value we're looking for, which is 100. So the answer to this question is 1 minus norm.dist, so brackets B7, B5, B6, and true. And that's 15.86%, and that's also the survival function. And survival function is not something that I recall being covered in the course. So I would consider that to be a little bit of a trick question, and I consider a lot of the questions in the assessment to be trick questions because they were not fully and comprehensively covered in the course. So now we've got a question about instruments. The length of life of an instrument produced by a machine has a normal distribution with a mean of 12 months and a standard deviation of 2 months. Find the probability that an instrument produced by this machine will last between 7 and 12 months. So you've got your mean lifespan is 12 months. You got your standard deviation is 2. You got your lower bound is 7. And your upper bound is 12. So you got your probability of the upper bound equals norm.dist brackets B7, B4, B5, true, which is 50%. And you've got your probability of your lower bound, is equals norm.dist B6, B4, B5, true, which is 0.6%. So now we're going to check the probability that it's between 7 and 12 equals B9 minus B10 is 49.379%. So now we have a question about archery. In a certain type of archery competition, Laura hits the target with an average of 2 out of every 3 shots. The shots are independent of each other. During one such competition, she has 10 shots at the target. Find the probability that Laura hits the target exactly 9 times. So you've got the number of shots, which is expressed as N, is 10. You've got the successful hits, which is expressed as K, is 9. And you've got the probability of hitting the target is 2 divided by 3. And so the binomial probability for this is going to be binom.dist brackets B6, B5, B7, false. And you've got 8.67% probability. So now we have a question about computers. So for a certain type of computers, the length of time between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. John owns one of these computers and wants to know the probability that the length of time will be between 50 and 70 hours. So the battery mean life is 50. Standard deviation is 15. The lower bound is x1 is 50. And the upper bound x2 is 70. So probability of the upper bound equals norm.dist brackets B8, B5, B6, true. That gives you a 90.8%. Probability of the upper bound equals norm.dist brackets B7, B5, B6, true, and it's 50%. So the probability is equals B10 minus B11 is 40.87%. So now we have a question about counters. Bag A contains 4 blue and 5 yellow counters. Bag B contains 3 blue and 6 yellow counters. A counter is picked at random from bag A and placed in bag B. A counter is then picked at random from bag B. Find the probability that the counter picked from bag B is yellow. So we've got the probability that the move is yellow equals 5 divided by 9. And probability that you pick yellow, given yellow, is 7 divided by 10. So you've got probability move blue is 4 divided by 9. And probability pick yellow, given blue, and it's 6 divided by 10. And probability that you're going to pick yellow is B7 times B6 plus B9 times B10. And so you have a 65.56%. So the next question we have is going to be about basketball. A certain basketball player scores 60% of the free throw students she attends. During a particular game, she gets 6 free throws. What is the probability that she scores on exactly 4 of the 6 shots? So the number of free throws expressed as N is 6. The number of successful shots expressed as K is 4. The probability of scoring is 60%. And so the binomial probability for that is going to be binom.dist brackets B6, B5, B7 brackets false, and it's 31.1%. The next question that we have is going to be on marksman. A marksman finds that on average he hits a target 4 times out of 5. If he fires 4 shots, what is the probability that he has more than 2 hits? So total shots expressed as N is 4. Probability of hitting the target is 80%. X is the number we're looking for, which is 2. And the probability is binom.dist brackets 3, B4, B5, false, plus binom.dist brackets 4, B4, B5, false, and the total probability is 81.92%. And that's all the questions covered in the assessment. And some of the questions that were covered in the assessment were actually put in Module 1 or Module 2 because I just wanted to have like one tab in the spreadsheet for each subject. So that's all we covered. And then if you decide to take the course in Alison, you'll see that what they covered in the assessment was not necessarily what they covered in the course. And I think that they did it that way because they wanted people to utilize their tutoring services. And I'm sure that they're very good tutors. They're much more knowledgeable than I am about statistics and probability and chance. And they can do it by hand. They're able to make all of these calculations by hand, whereas I did it using Python and Excel. So that concludes this video. If you like my video, please like and subscribe. And thank you very much for watching my video. I look forward to making some more videos for you on technical subjects in the very near future.